Welcome to a new section, Date and Time. Many programs need to handle time, whether it's logging when an event occurred, scheduling future tasks, or measuring performance. Python handles these concepts primarily through its built-in datetime module. 1. The datetime module classes. The datetime module contains several classes. The three most important are the date class, which holds year, month, and day information, the time class, which holds hour, minute, second, and microsecond information, and the composite datetime class, which holds all of this information combined. We must import the module before we can use any of these classes. 2. Creating a date object. To create a specific date, you call the datetime.date constructor, passing the year, month, and day as arguments, all of which must be integers. Once created, the resulting date object has attributes like .year and .month that allow you to easily access the component parts of the date. 3. The datetime object. The datetime.datetime class is the most comprehensive, combining all the components. To create one, you pass the year, month, and day, followed by the hour, minute, second, and optionally microsecond. Just like the date object, you may access the individual components using attributes like .hour or .minute. To summarize, the datetime module gives us structured ways to handle time. Our next lecture 25.02, Time since Epoch. See you there. Welcome back. To truly understand how computers handle time, you must know the concept of epoch time, often called Unix time or POSIX time. This system allows computers to compare and store timestamps as simple, universally comparable numbers. 1. What is the epoch? The epoch is a fixed point in time, January 1st, 1970, at midnight Coordinated Universal Time. The epoch timestamp is simply the total number of seconds that have passed since that exact moment. Computers prefer this because a single integer or floating point number is easy to store, transfer, and sort globally, without dealing with time zones or daylight-saving rules. 2. Getting the epoch timestamp with .timestamp parenthesis. Any datetime object has a useful method called .timestamp parenthesis. When you call this method, it returns the time in seconds since the epoch as a floating point number. This is what you would use to convert a human-readable time into the machine's numerical time format for storage in databases or system logs. 3. Reversing the conversion with .fromTimestamp parenthesis. The datetime.datetime class also provides a class method called .fromTimestamp parenthesis. You pass it an epoch value, a float or an integer representing seconds, and it returns a full datetime object. This is how you convert machine time back into a format people can read. The ability to switch seamlessly between these two representations is fundamental to working with time. To summarize, epoch time is the numerical backbone of timekeeping. Our next lecture 25.03, Finding the Current Date and Time. See you there. Welcome back. The frequent task when dealing with time may be simply getting the current date and time, for logging, timestamps, or display. Python's datetime module makes this extremely easy using two primary class methods, .now parenthesis and .today parenthesis. 1. Getting current date and time with .now parenthesis. The static method datetime.datetime.now parenthesis returns a new datetime object representing the exact current moment according to your system's clock. It is the most precise way to timestamp an event, as it includes the microsecond information. The object returned is, of course, a datetime object, meaning it contains all date and time components. 2. Getting current date with .today parenthesis. If you only need the current date, the year, month, and day, you may use datetime.date.today parenthesis. This method returns a date object, not a datetime object. It's often cleaner to use this when the time component is irrelevant, such as recording someone's birth date or the current business day. 3. Extracting components and timestamping. Once you have a current datetime object using .now parenthesis, you can apply everything we learned previously. You may use the attributes like .month or .day to get specific components, and you can easily convert the current moment into its numerical epoch timestamp using the .timestamp parenthesis method. To summarize, getting the current time is simple with .now and .today. Our next lecture 25.04, Combining Date and Time. See you there. Welcome back. In real-world data, you may encounter dates and time stored in separate fields, perhaps one column for the date and another for the time. To perform time-based calculations or conversions, you must merge these into a single datetime object. This section shows you how to use the datetime.combine parenthesis class method. 1. Using datetime.datetime.combine parenthesis. This is a class method that takes exactly two arguments, a date object and a time object. It then returns a new single datetime object with the components of the first object and the time components of the second. This is a simple way to merge date and time components in Python. 2. Modifying components with .replace parenthesis. Once you have a datetime object, you may need to adjust only a few components, perhaps setting the time to midnight or correcting the year. The .replaced parenthesis instance method allows you to create a new datetime object based on the original, substituting only the fields you specify. The original object is unchanged, and the remaining components are carried over to the new object. 3. Extracting and combining components. A scenario is taking the current date and setting the time to exactly midnight. You can do this by first calling the .date parenthesis method on the .now parenthesis object to get the current date part, and then combining that date part with a new, manually created time object representing midnight. This shows the flexibility of combining methods for precise time manipulation. To summarize, you can now build and modify date-time objects from different pieces. Our next lecture 25.05, Sorting Dates. See you there. Welcome back. When dealing with data like system logs, transaction records, or scheduled events, you often need to organize them chronologically. Fortunately, datetime objects in Python are natively comparable, meaning you can use standard sorting functions directly on lists of these objects. 1. Comparing datetime objects. Python makes time comparison intuitive. You can use standard comparison operators like less than sign, or greater than sign directly between any two date-time objects. The comparison is based on the absolute point in time. If one object is chronologically earlier than another, the comparison will reflect that. This is the foundation of sorting. 2. Sorting in ascending order. Because date-time objects are comparable, you may simply pass a list of them to Python's built-in sorted parenthesis function. By default, it will sort the list chronologically from the earliest time to the latest time, known as ascending order. The output here clearly shows the January date comes first, followed by March and then May. 3. Sorting in descending order. If you need to see the most recent events first, a common requirement for log displays or news feeds, you may use the optional keyword argument reverse set to true. This sorts the list in descending order, meaning the latest date and time will appear first in the resulting list. To summarize, sorting time is straightforward in Python because the date-time objects handle the complexity. Our next lecture 25.06. Sleep. See you there. Welcome back. While the datetime module is great for manipulating dates, a separate module called time contains functionality for system-level time control. You may pause your program's execution using the time.sleep parenthesis function. This is essential for controlling resource usage or adhering to rate limits when interacting with external systems. 1. Importing the time module. Unlike the datetime module, which contains the datetime class, the sleep function belongs to the separate, lower-level time module. To use it, you must import time. The time.sleep parenthesis function takes a single argument, the number of seconds, as a float or an integer, for which the program should pause. During this pause, the program consumes minimal CPU resources. 2. Practical example. Simple countdown. A demonstration is a countdown timer. By placing time.sleep parenthesis inside a loop, we can control the pace of execution. In this example, the program prints the countdown number and then pauses for exactly 1 second before iterating to the next number. This demonstrates precise, controlled delays. 3. Pausing for sub-second durations. Since time.sleep parenthesis accepts a float, you can pause for less than a second, such as half a second. This is useful for very precise rate limiting or creating smooth, though basic, text-based animations. Just remember that the operating system guarantees a minimum pause, but the actual pause may be slightly longer due to system overhead. To summarize, time.sleep parenthesis is your tool for scheduled inaction. Our next lecture 25.07. Knowing the execution time of a program. See you there. Welcome back. Measuring the execution time of a function or a block of code is a fundamental skill in optimization and debugging. It helps you identify performance bottlenecks. We can achieve this easily by using the datetime.now parenthesis method twice and then calculating the difference, which introduces a new concept, the time delta object. 1. The measurement principle. The method is straightforward. First, you capture a start time snapshot using datetime.now parenthesis before the code runs. Second, you capture an end time snapshot immediately after the code finishes. Finally, you subtract the start time from the end time. The difference is the exact time elapsed during the execution. 2. Calculating elapsed time. In this example, we use time.sleep parenthesis to simulate a long task. When we subtract start time from end time, Python creates a new type of object called a time delta object. This object represents a duration, or the difference between two date-time objects. The output shows the difference in hours, minutes, seconds, and microseconds. 3. Extracting total seconds. While the default time delta representation is human-readable, for performance analysis or precise calculations, you often want a single floating point number representing the total duration in seconds. The time delta object provides the .total seconds parenthesis method for this exact purpose. This gives you a high precision number that you can use for comparisons, benchmarks, or logging. To summarize, you can now easily benchmark your own code. Our next lecture 25.08. Validate credit card use case. See you there. Welcome back. In this lecture, we apply our knowledge of the date-time module to a critical real-world problem. Validating if a credit card is expired. This involves parsing a date string and comparing it against the current date. 1. Understanding credit card expiry. A credit card expiration date, typically presented as month/year, is valid until the very last day of that month. For example, a card expiring in 1/2/25 is valid until midnight on December 31st, 2025. Our challenge is to convert the input date into a date-time object representing the first moment after the card expires, and then compare it to today. 2. Parsing the expiration date string. We use the powerful datetime.datetime.strptime parenthesis class method, which means string parse time. It takes the date string and a format code string. The format code %m/%y tells Python to expect a 2-digit month, a slash, and a 2-digit year. Since the input only provides month and year, strptime defaults the day to the first of the month. We then use .date parenthesis to get only the date part. 3. The validation logic. The key trick is to compare today against the first day of the month following the expiration month. If the card expires in November, we check if today is greater than or equal to December 1st. If it is, the card is expired. If it's earlier, the card is still valid. Image illustrating credit card expiry validation logic. If today is greater than or equal to first day of next month, then expired. This simple comparison leverages the native comparability of date objects we saw earlier. To summarize, you can use strptime and date comparison logic to validate expiry dates, making your application secure. Our next lecture 25.09. Project Management Use Case. See you there. Welcome to the final lecture of our date and time section. We will now apply our knowledge of date-time objects and time delta to a project management scenario, calculating future deadlines and determining the remaining time for a task. 1. Creating a time delta object. The time delta class, which we encountered when measuring execution time, is primarily used to represent a duration, a difference in time, not an absolute point in time. You create one by passing keywords like days, hours, minutes, or seconds. Here, we define a project duration of 30 days and 8 hours. 2. Calculating a future deadline using addition. The magic of time delta is that you may add it directly to a datetime object. When you add a duration to a datetime object, Python handles the complexity of calendar math, like rolling over months and years, and returns a new datetime object representing the date and time in the future. This is perfect for setting project deadlines. 3. Calculating time remaining using subtraction. To find the time remaining until a deadline, you subtract the earlier datetime from the later one. The result is, once again, a time delta object which tells you the duration between those 2 points. You may then access the .days attribute to get the whole days remaining, or use .total seconds parenthesis for a more granular view. To summarize, you now have a complete toolkit for handling dates, times, durations, and system time, covering everything from logging to project management. Our next lecture 26.01, Introduction. See you there.